Hi, this is Klaus from Electronics Unmasked. In this video we will create a versatile hardware for a number of different applications. This time I carefully thought about creating a versatile electronics hardware. I like analog gauges where I'm using a stepper motor that can be directly driven by an Arduino board. I have a number of applications in mind that I want to keep open as options. With this hardware concept, I want to measure an analog voltage or the frequency of a signal, or I want to connect a BME280 sensor, which is measuring temperature, air pressure and humidity. This way, I can use the hardware to display the speed, the rounds per minute of a motor, the climate data, the topographic height, and practically any measurement that produces an analog voltage or a digital value. I can tell you already now that there will be a stylish 3D printed casing for it again. The whole thing is in the style of a tachometer. For 3D printing, you might want to go the easy way with PCBWay, the sponsor of this video. You will find the CNC and 3D printing section on the website. You can easily upload your design data. And guys, I'm so impressed by the variety of materials I can choose from. Besides numerous plastic options, there is even metal, and it's great to see the price immediately with every change you make. In this concept, I'm soldering the stepper motor to the printed board. This avoids acoustic coupling from the stepper motor to the casing. By the way, this hardware is not restricted to any casing design. If you want, you can use it also for that retro-style casing as well. You will find it in earlier videos. Now let me show you the circuitry. Once again, we have an Arduino Nano. I want to use the analog input A0 to measure 3 different voltage ranges. I want to cover the ranges 0 to 10 volts, 0 to 20 volts and 0 to 30 volts. The voltage divider for 10 volts is made from two 15 kilo ohms resistors and a 2 kilo ohms trimmer in the middle for calibration. You get a range up to 20 volts using a 47K resistor with the second voltage divider. And with an 80K resistor, the range is up to 30 volts. The trimmers are always 2K. I calculated the voltage dividers with Excel. On the one hand, I wanted to understand how the tolerances of the resistors affect the voltage ratio. And on the other hand, I wanted to find the right resistance for the trimmers, which I need to compensate for tolerances and the actual resistor value that I find in my stock. Because not every resistance value that I have theoretically calculated is actually available. Back to the schematic. We keep the I2C pins open for the BME280 option. So I cannot use A4 and A5 for anything else. Pin D8 is used by a library for measuring the frequency. Here I might connect a trimmer to shift the trigger point for the measurement if necessary. Next, we have the LEDs, which I want to use for the dimmable lighting. Furthermore, I want to use that feature when measuring revolutions for an engine, for example. And the yellow LED shall light up as soon as a certain value is exceeded. The red LED lights up at a higher value and will start blinking at the highest value. All 3 trigger values can be defined in the code. Finally, there are the connections for the coils of the stepper motor, each with a flyback diode, which is providing that the Arduino is damaged by inductive voltage spikes caused by the stepper motor's coils. The resistors of 68 ohms are reducing the current consumption and the noise of the stepper motor. The resistors slightly reduce the torque of the stepper motor, but it's still sufficient for my purpose. Next, let's have a look on the first part of the code. I'm using a library for the stepper motor, which requires the definition of the pins that are connected to the coils. Here's a little tip. If your stepper motor rotates in the wrong direction, you don't have to change your soldered connections. You can simply swap two connections here in the code definitions and the motor will turn in the other direction. The code is pretty versatile for other applications. Virtually all functions are controlled by variables, all of which you can define according to your needs. For example, the variable full deflection is the full deflection in steps. This practically defines the maximum pointer deflection or the maximum angle of the scale. Here are the speed and dynamics settings for the stepper motor. This is actually a very interesting topic that I will cover in one of the next videos. Then there are settings for the LEDs again to define the pins and the brightness. And then there is the setup where we have to define the pin mode of some pins. I'm glad you made it up to here. Don't forget to subscribe. Then you don't miss coming episodes where it's about the new Arduino code for other applications, lots of tests and of course the 3D printing of the housing. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.